Hi there, welcome back. This is the second video on transformations. Make sure you have understood the translations from the previous video, and then now we come to the second video, the reflections. Now I was trying to think how exactly can I explain these reflections, and then I said let me make use of a paper. I have a piece of paper here. This piece of paper, I folded it 2 times, and then after folding it 2 times, I used a pair of scissors to cut it here. Now when I open it, right, or let me open it this way. When I open it, you see we have a triangle which we obtained after cutting that edge with a pair of scissors, right? And then I open it the second time. All right, here it is. I have opened it the second time. You see what we have now? We have a Cartesian plane, and this is our x-axis, this is our y-axis, and you should see we've got a triangle here in the first quadrant and a triangle in the second quadrant, right? Remember, these two triangles were the same when we folded this paper in half, right? After opening it, we have 2 triangles, right? And the distance from this edge coming to this vertex of this triangle, right? Please note that distance from the y-axis coming to this vertex is exactly equal to the distance from this one to that one, right? So we can say, when we look at transformations, if this is the original image or the original figure, this one is its reflection or its image, right? And also I want you to take note of the fact that if you assume that this triangle is your head, and this is the back of your head, and this is the front of your head, probably this is your nose, right? If we take the y-axis as a mirror, and when you look at yourself in the mirror, do you see the back of your head or you see your face? All right, this is exactly what's happening with reflection here. If we assume that this is the mirror, or if we call our y-axis the mirror line, you will see that this original figure looks at the mirror, sees the face of the reflection, right? So when you are looking in front of the mirror, standing in front of the mirror, when you look at yourself, your image is looking at you as well. So in reflections, the original and the reflection, they look at each other, right? So we've got triangles here. This is the original and this is the image or its reflection. And we have the middle line, the y-axis, we call it the axis of symmetry. That is the line which is working as our mirror line. All right, I have drawn a triangle here. I have triangle ABC, and this triangle ABC, I am assuming that this is the original figure, right? And this original figure, if I can assume, or if I can say this is your head, you are looking at a mirror. This one becomes your reflection, and the reflection will be looking at you. We can say, if this is your nose, this is your nose in the reflection, right? And the back of your head, this is the back of your head also in the reflection, right? So this is looking at this one, and this one is also looking at this one. Now since it is translation, we want to look at the coordinates of the original figure and the coordinates of the reflected figure. Let's start with A. The coordinates of A here is 2 s2 5. 2 s2 5, and A has been mapped onto its first image, which is having coordinates -2 s2 +5, -2 s2 +5. And then we have B. The coordinates of B, okay, this is B, is 4 s2 5, and then B has been mapped onto its image, that is, this is the image of B. The coordinates is -4 s2 5. And then C also, this is our original C, and the coordinates for original C is +4 s2 +2, 4 s2 2, and C is being mapped onto this image with -4 s2 2, -4 s2 2. All right, this is what I want you to take note of. 2 5 2 5. The only difference is the sign. This was +2, it becomes -2. This was +4, it becomes -4. This was +4, it becomes -4. So we can say in general, x s2 y is mapped onto, this is negative, so -x s2 y. So this is the general rule for what we refer to as a reflection along the y-axis. So this is the original image, and we have reflected this original image along the y-axis as the mirror line to produce A, B, C as the first image, right? If we do that translation, the only change that happens to our coordinates is the sign on the x point. We call this reflection on the y-axis. This is the reflection on the y-axis. All right, I have explained to you how to reflect a point or a figure along the y-axis. Now I have line DE. Could you reflect line DE along the y-axis and give us the new coordinates of this reflection? Line DE. Remember the rule for reflection along the y-axis. XY is mapped onto -xy. For reflection on y-axis, it's only the x that changes sign, right? So if it was 2s/5, it becomes -2s/5. This is 6s/1. So if it is reflected on the y-axis, it becomes -6s/1. Let's go to, this is -6s/1. So our D is here, -6s/1. And then +8s/3 becomes -8s/3. Remember, reflection on y-axis, it changes sign for the x. So it becomes -8s/3. Our -8 here and our 3 is here. So this is E, and then you join the 2 points to create this line DE. So we are saying this line DE is the reflection of line DE here along the y-axis. Now let's look at reflection in the x-axis. Okay, now this one is a reflection along the x-axis. We still have the same triangle ABC with the same coordinates. Now we want to reflect triangle ABC along the x-axis, or our x-axis is now our mirror line. Now if we reflect this triangle along the x-axis, the image comes to the 4th quadrant, right? And remember, the distance from the axis to the point should be the same as the distance from the axis to its image. So we are saying there, if this is 2 units, it means also our C is supposed to be here, right? And then from that, let's try to put together the rule for reflection in the y-axis. The coordinates for C is 4s2, 2. So our C here we are saying is 4s2, 2. And C has been mapped onto the second image. Remember, the first image was in reflection in the y-axis. The second image is now 4s2, negative 2. 4s2, negative 2, right? Remember, for the x-axis, our rule was saying x is to y is mapped onto negative x is to y. This was a reflection on the y-axis, right? Now this is a reflection in the x-axis. It was 4s to positive 2. It is now 4s to negative 2, right? Reflection there. So we can say in general here, this is x to y mapped onto, this is x to, the y was positive, it has become negative, so this is negative y. So you should know that, or should always remember that a reflection in the y-axis, the x changes sign, and then reflection in the x-axis, the y changes sign, right? Now you can pause the video and reflect 1, 2, 3 points. Okay, we've already done C. Reflect point B and point C along the x-axis and draw the triangle to see if you'll be able to do it. Okay, I hope you managed to do it. Now let's come up with the coordinates. B, our B is 4s2, 5 is mapped onto the second image of B with coordinates. Remember, we said the y changes sign to be negative. If it was negative, it becomes positive. If it was positive, it becomes negative. So it's 5, it becomes negative 5. The x remains the same, so it's 4s2 negative 5, and then A has coordinates 2s2, 5 is mapped onto second image of A with coordinates. Remember, the x is the one with the y is the one which changes sign, so 2s2, 5 is 2s2 negative 5. Now let's plot the points. We said this is C, the second image, and then B The second image is 4s to negative 5. This is our 4 and our negative 5 is here. So our B is here. And then our A is 2s to negative 5. So it's 2s to negative 5. So it is here. So this is our A. And then we join the 3 points to create our triangle, which is the reflection of triangle ABC in the x-axis. So this is the reflection of ABC in the x-axis. So our rule for reflection in the x-axis is xs to y is mapped onto xs to negative y. So these are the two rules that you are supposed to remember when you are doing reflections. Remember, practice makes perfect. You cannot look at this video and think that you have mastered the concept. Mathematics is a practical subject, so you need to sit down, practice and practice and practice. The more you practice, the more you master these concepts, the easier they become. And remember, practice makes perfect, and in mathematics, perfection is a distinction, a very good distinction. So continue practicing and continue enjoying.